The way AI learns is by studying data sets that train and teach it how to respond to given inputs. The training process is very compute intensive and uses data sets that are called large language models, or LLMs. So you've heard of these with OpenAI's ChatGPT, or Microsoft Copilot, or Meta's Llama. These LLMs are very important, and they're getting bigger by the day, with training models approaching and exceeding 1 trillion parameters. So this is a huge problem, and it puts data movement front and center. Now, training just covers the first part of the process. The other part is called inference, and that's when a user generates an input to drive the model to produce an output. So while training involves huge data sets and intensive compute, it happens once or not very often. Inference, by contrast, has much smaller data sets and requires much less compute, but it happens all the time and with user expectations on latency. So think about Google trying to finish your search string for you as you're typing it, or Amazon recommending related products, or when you're asking ChatGPT to write that Christmas card for you. These things happen all the time and for millions of users. So the real issue comes in the form of power demands that AI brings. Training takes a huge amount of compute and data, which drives very large power demands. Inferencing, however, is where the bulk of AI power is spent. As an example, Google is now inserting some AI-generated responses into search queries. And depending on the user, this might be super useful or not, but the bottom line is that putting this text in the response has a significant cost to Google that's estimated to be in the billions of dollars due to the extra compute and power that's associated with it. If this AI trend is to continue as projected, power and costs have to be brought under control, and data movement can certainly be one area where significant cost savings can be realized. Moving data is expensive, so think about it. How many electronic devices are between your TV and that movie being served up by Amazon or Netflix? So yeah, the first obvious solution is to not move data. To that end, one of the things we're doing at MIPS is meeting compute where it happens. This means creating compute products that enable processing to happen as close to the data source as possible and not need to be transported across the country or even across the data center to the compute nodes. Of course, this isn't always possible, and inevitably data needs to move, right? That movie has to make it to your screen. So we're also looking into making data movement as efficient as possible. We're specifically looking into the DPU space, where current solutions consist of either general purpose compute or specialized acceleration, or some mix of the two. What if we can more finely blend the ease of use of general purpose compute with that of the specialized compute? Again, solving compute where it happens instead of having to send packets off chip or even on chip to another accelerator.